Hi all, I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Having discussed relations in part 1, now it is time to discuss functions. Again, I would like to discuss in detail. Now let us proceed with functions. Let us recall from first PUC some of the basic things which will make the things easier for us. Now let us try to define what is a function. Now function is defined as function is a special type of relation where every element have a unique image. Let us try to understand this, what has been written. I'm saying here function is a special type of relation. Oh, it means every function is a relation, but every relation need not be a function, where every element have a unique image. Unique means one. Now let us try to understand what is this image, all this. For that, let us go for arrow diagram. See carefully. Example number 1. Yeah, it's visible. Yeah. Now I will take some elements 1, 2. Let us suppose A here. Then here 7, -1, 2, 3. Now let us suppose this is the first set A. This is first set B. I am going to give 3 examples. You have to quote among these 3 examples which example satisfies this definition, that every element should have one image. Okay. This is the first problem. Think. Till I complete all, think. And one more I will give. Let it be very clear. See carefully all this. Okay. Now let us name this. This has F1, this has F2, this has F3, and this is F4. All are relation. Now we have to judge among this which is a function. Definition of function is every element should have one image. Now wherever it is not linked, we call that as image. So image of 1 is 2, image of 2 is 7. Okay. Now first see here, every element of the first set should have one image in the second set. Okay. So image of 1 is 2, one image is there. Image of 2, 7, only one image is there. But there is no image for A. Here we said every element should have. So since A don't have any image, hence what? F1 is not a function. So it's not a function because A don't have any image. I have given the reason as well so that you can understand better. Yeah, recording is going on. Yes, correct. Now see F2. What is the image of 1? 2, only one image. What is the image of 2? 3, only one image. What is the image of A? It is 7 as well as 3. We have 2 images for the element A. There was no problem with 1 and 2. Problem is A. So even if one element disobeys, it's not a function. So let's mention, since element A has more than one image, namely, which are those more than one image? Image of A is 7 and 3. Hence, not a function. Okay. Next, come to third example. So, hence F1 also, hence who is that? F2 is not a function. Okay. Now come to this. What is the, for F3, what is the image of 1? 3. What is the image of 2? 7. What is the image of A? 2. Every element have got only one image. Since every element have got only one image, therefore F3 is a function. Come to F4. What is the image of 1? 2. Only one image. What is the image of 2? 7. Only one image. What is the image of A? 2. Only one image. See, many students will be thinking, now what do you think? F4 is a function or not a function? Some student will think that since 1 and A have same image, 2, therefore it's not a function. I repeat, since 1 and A have the same image, hence F4 is not a function. Many will think, no, it is a function again. Why? Read this definition. It is a special type of relation where every element should have unique image. Every element should have one image. Whether it is having same image or different image, that's not a question. But it should have only one image. Yes, 1 and A have same image, but they have one image. Hence, F4 is a function. F4 is a function. Now in this, I want some of the terminology to be understood by you. These two no need to discuss because both are not function. Only for function, I want you to understand some terminology. What are those? Now you see, the element 2, 7, 3 are called images. 7 is image of 2, 2 is image of A, 3 is image of 1. Now, we are going to write 7. For example, this 7, I can write as, see carefully, 7 is F3 is scanning 2 to 7. So, F3 of 2. You can think like this, no? A is your home, okay? B is your college, and you have to move from the place 2 to 7, and you want a medium of transport to move from home to college. It can be by two-wheeler, it can be by car, it can be by bus, or it can be by walk also. So this F3 is your transport. So F3 is taking you to the destination of 7. That's what F3 of 2 is equal to 7. Similarly, see this 3. F3 of 1 is what? 3. Because F3 is taking 1 to 3. Then what about this? F3 is taking A to 2. So this is F3 of A. So these are called images. Having understood that these all are images, what are these called? This numbers in the set A, 1, 2, A, all these elements are called pre-images. Now as soon I have given this terminology pre-images, now majority of the students are the confusion that, sir, we always get a confusion that which is pre-image and which is images. For that, let I give you one simple idea. Okay. For a while, assume that set A is yourself. Okay. You represent set A. Set B is the mirror. So set B is the mirror. You are set A and set B is the mirror. So when you stand in front of the mirror, B, where is the image formed? The image is formed on the mirror. And you are the primary image. You are the first image. You are the pre-image. First means what? Pre. So you are the first image and image is formed on the mirror. I hope this logic is clear. Now, since F3 is now a function, Now how are we going to write function from A to B? See carefully. Since f3 is a function, we are going to write this one as f3, because I've taken f3 here, is a function from A to B. Okay, A to B. In all our problem, whenever we see A to B, first set all the set of all the element having image is known as domain. What is here known as? Domain. What the second set B is known as? Codomain. Codomain. And set of all the images are known as range. Range. See carefully, range. It is the element 7, 2 and 3. And 7, 2 and 3 is contained in the codomain. So I can always say that range is subset of what? Codomain. It can be equal also, provided I have one more element here mapping to -1. Okay. Then in that case, range and codomain are same. We should understand what is domain, codomain, range, because depending on this, we are going to have types of functions. Let's take this also. Now in this, one more thing, range, no, in place of writing like this, we can also write f3 of A. Nothing but f3 is taking the element of set A and mapping to codomain. Okay, now let us come to this. f4 is also a function. So we write f4 is a function from A to B. What is the domain? Again, A is the domain. What is the codomain? B is the codomain. Because since I've taken the same set, so no change. But what is my range? Coming to the range, it is f4 is taking A and mapping to the element 7, 2. That's it. So again, don't forget 7 and 2 are what? Images, and 1, 2 and A are what? Pre-images. Okay. So with this, we are ready to go ahead with second PUC functions. Okay. Make a note. So one more thing, no, you can write like this here. Better let us go with convention. So range is actually f3 of A. Okay. Fine. Make a note. Dear students, having understood what is a function and the terminology, now it is time to talk about types of functions. Now let us move on to types of functions. Under this, the first one is one function. There is one more name for this, injective function. You should know both the terms. Injective function. Now what is injective function? It is a function in which every element have distinct image. I repeat, every element should have distinct, nothing but different images. Different image. See carefully. If I take a function f1, so as soon as I said function, no, every element should have one image, unique image. So let's suppose 1 is there, 2 is there, 3 is there, 7 is there, 8 is there, -1 is there. Okay, and 10 is also there. Now 1 I am mapping to -1, 2 is mapped to 7, and 3 is mapped to 10. Now just see first whether every element have one image. Yes, image of 1 is -1, image of 2 is 7, image of 3 is 10. Every element have one image. Next question is whether they have different image. Just see, image of 1 is -1, image of 2 is 7, and image of 3 is 10. All have got different images. This we call one function or injective function. Now here, when we want to prove it is one function, how we are going to go ahead? Before we just I give the definition, recall this element, that is 7, -1 and 10 are called images, and this element are called pre-image. Okay, pre-images. Now, see carefully. When we are mapping, we have got images. Now, if I take F1, I'll try to give the definition, but before giving definition, no, I just want to understand what I just want to convey. Is 1 equal to 2? Is 1 equal to 2? No, they are not. Then f of 1 is minus 1. F of 1 is minus 1. And f of 2 is 7. F of 2 is 7. So now question is minus 1 and 7, are they same? No, they are not same. But what is minus 1? F of 1. Just listen carefully. And what is 7? F of 2. Try to understand what I am trying to make you understand. If I assume for a while x1 is, 1 is x1 and 2 is x2. So here I have it like this. 1 is what? X1 not equal to, what is 2? X2. So what am I saying here? If pre-images are different, then their image should be also different. That's what you see. F of 1. What is 1? I have taken 1 as x1 and I have taken 2 as x2. So put here f of x1 is not equal to f of what is f of 2? F of x2. So if pre-images are not equal, this implies even their images are not equal. This is the definition for 1 function. Other way round. What is other way round? Or if images are equal, then their pre-image is also equal. Both are equivalent. So here we have went from pre-image to image, whereas here we have went from image to pre-image. Okay. But coming to the definition, the way we are going to prove, we are going to use this one. After we are assured that it is 1 function. I thought let you have both the information. Okay. And this should happen for all the element x1 comma x2 belonging to domain. That is A here. Similarly here. Now one question will come, sir, what if it is violating this condition? Any function which is not 1, 1, it is many one function. Now see, for example, this thing will be still more clear here. Okay, just pay attention. I'll take the same element to make it clear. Now see carefully. F2 will name this. So now check, is it a function? Every element have unique image, yes. But C8 have got two different pre-image, or I can say image of 1 and 3 is 8. It has got same image. So now let us write the way I wrote here. See carefully. F2 is carrying 1 to 8. F2 is carrying 1 to 8. And F2 is also carrying 3 to 8. F2 is also carrying 3 to 8. Now since 8 is equal to 8, I can write F2 of 1 is equal to F2 of 3, because 8 is equal to 8. But now see carefully. Images are equal, but what about pre-image? 1 is not equal to 3. That's what it is, not 1, 1, nothing but many one function. Any function which is not 1, 1 is many one. Again, I would like you to recall, okay, when we discussed the first PUC part, no, as soon I equated something and I got the image, okay, you should understand always henceforth what? The term which is present inside F is your pre-image, whereas this entire thing, let it be y or f of x, we call it is image. That's what's happening here. F2 of 1 and 3 both are mapping to 8. Nothing but 8 is what? Image. And this is also what? F2 of 1 and F2 of 3. But the thing is, 1 is not equal to 3. Therefore, it is not 1, 1. That is, I got it here. That is, F2 is many 1. Many 1 function. Any function which is not 1, 1 will come under many 1 function. Okay. I hope the things are clear. Make a note. Dear students, now let us move on to the next type function. That is onto function. Now what is onto function? Any function which have got, now see this very carefully, understand. For 1, 1 and many 1, we have went from domain to codomain. Whereas for onto function, we are going to come from codomain to domain. Always the first set is domain in function as soon as I say, because even if one element is not mapped, it's not a function. And then see B. See carefully this example. Now, let us map. Now, as I said, you have to just check whether every element of codomain have got pre-image. Even if one element is missed, that this element don't have a pre-image, then it's not onto. In short, see this. What is the domain of this? One by one, just first see this. Domain of this is what? First set A. Why? All the elements have got image. Even if one element don't have an image, it's not a function. When it is not a function, there is no talk about types of function. So domain is A. Elements are 1, 2, 3, minus 1. What about codomain? Coming to codomain, it is the entire second set B, that is 7, 8, 9. What is the range? Coming to the range, it's all the element having the pre-image. 7, whether 7 has pre-image? Yes, 2. 8 has pre-image? Yes, 1. 9 has got 2 pre-images, no problem. But it should have pre-images. Yes. Now in this case, if you see, both range 7, 8, 9, codomain 7, 8, 9, both are same. So whenever you see range is equal to codomain, then we say it is onto function. Other name for this is surjective function. What is surjective function? Any function which has every element in codomain should have a pre-image. Now how to define? Now see carefully the way I'm going to define this in general. For every, see this carefully, definition for onto. For every y belonging to codomain. So for every y belonging to codomain, there exist, let's write here, for every y belonging to codomain, there exists an element x. There exists an element x where? In domain, such that f of x is equal to y. So this map f will take x to y. Okay, only then we say it is onto function. When we are going to have a 5-mark question on proving that it is what? Onto. After we comment is onto, we are going to conclude like this. Okay. Now, next question is, let us suppose, okay, when you this is mapped. Okay. Let us suppose there is few element, even one element not mapped, nothing but it's not obeying this condition. Then what type of function it is? Let us take that. That is known as into function. What is into function? Any function which is not onto, nothing but I should have minimum one element in the codomain, not having the pre-image. For example, okay, 2 already taken, some element will take 4. See carefully. F, okay, 2 will take this. Now see carefully, it need not be always AB, it can be CD, okay, LM. Now see this, 1 is mapped to -1, 2 is mapped to 5, 4 is again mapped to -1. Now see carefully, first element of A, 1 is mapped to -1, 2 is mapped to 5, 4 is mapped to -1, all are mapped to different element, therefore it's all are mapped to, I mean to say all are mapped to one element of B, nothing but they have one image, hence it's a function. But so the element of A, that is 1, has got one image -1, 2 have got 5 as one image, 4 has got one image -1. But you observe 3 don't have any pre-image. Since 3 don't have any pre-image, because of this element, F2 is not onto. Any function which is not onto is what? Into function. And in this case, if you see the range, what is the range of this function 5 and -1? And codomain, you see, what is the codomain of this problem? The entire second set B, and it is 3, 5, -1. So 5 and -1 is contained here. 3 is an extra term, so this is a subset of B. So whenever range is subset of codomain, whenever range is surely a subset of what? Codomain, then it is into. C for onto, range is equal to codomain. Understand this carefully. Okay, so that is into function. We don't have any one more name the way we have for onto and one more. Last type is bijective function. What is bijective function? Understand carefully. What is bijective function? A function f is said to be bijective if it is both 1, 1 and onto. Only then we say it is what? Bijective function. Now for example, see this. If I take A to be 1, 2, 3, then 7 here, 8 here, and -1. What is the image of 1? Let us suppose I'll map to this 8, then 2 to 7, and 3 to -1. First, check, is it a function? Image of 1 is 8, one image. Image of 2 is 7, one image. Image of 3 is -1, one image. And all these have different image. So it is function as well as 1, 1 function. Next, see the range. Range is 7, 8, -1, which is same as what? Codomain. Therefore, it is both 1, 1 and onto. And here one necessity condition for a function to be bijective is number of element in domain should be equal to number of element in codomain. What I mean to say is, if I add one extra term 5 here, now it's not onto, it is 1, 1, and since it's not onto, it's not bijective. Similarly, let us suppose I'll add one extra term here. Now it's not a function itself. Why 4 don't have any image? That's what I'm saying, that number of element in domain and codomain should be same. So with this, we are ready to solve some of the problem from model question paper. Okay, make a note of this. Dear students, as I said previously that as and how I take the concept, let us take the problem. Now, this question is from model question paper number 1. Model question paper 1. Coming to 1 and 3 markers, both are from relations, which we have already discussed in part 1 of this video, relations and functions chapter. Now, this is a 5-marker question. Question says, state whether the function f from R to R, so domain and codomain both are R to R, defined by f of x is equal to 3 minus 4x is 1, 1 onto or bijective. Justify your answer. See, I prefer you, since here they have said state whether, no, check once whether it is 1, 1 onto or not. See, for this, no, take arrow diagram. In our usual class, no, first let's say banana there, and we'll have some fun there when I say that. So now I have got, since real number it is, so let's suppose 0, take some numbers, okay, -1, -2. Now substitute here, okay, f of x is equal to 3 minus 4x. When I put x is equal to 0 here, what I'll get? 3 minus 4 into 0 is 0, I'll get 3. So 0 is mapped to 3. Okay. Now put x is equal to 1 here. What you will get? f of 1. This is the same thing I've copied here. What I will get? 3 minus 4 into 1. So I'll get 3 minus 4, nothing but -1. So 1 is mapped to negative number somewhere here. Okay. Similarly, if I take -1, again substitute here. f of -1. Again substitute here. What we will get? 3 minus of 4 minus 1. So 3 is equal to -2 minus plus 4. I will get what? 7. What I'm trying to convince you is just having some plot like this. One thing is very clear. Every element here have got different image. Therefore, it is 1, 1 function. From diagram, very clear it is. And see, I'll give one more hint. Whenever power is odd, no, power of x is what? 1. Whenever power is odd, it's always 1, 1 function. Because only power even, no, power even, that is nothing but x square, x power 4, will convert negative to positive. That time I have to check. Okay. But anyway, for you, how to go about, I have just taken up a diagram to be very clear. If here they could have given proof that, no, we could have not checked like this. Since they have said state whether, no, so we have once checked, yes, it is both 1, 1 and onto. Now I have to prove it. In examination, you can avoid this working. Okay. Now solution part. First take the data. It is a function from where to where? R to R. And f of x is given as 3 minus 4x. Okay. Now I have to go for proving 1, 1. So to prove what? 1, 1. That is the heading, so that you understand what we are trying for. Now for 1, 1, we have to assume images are equal. Nothing but suppose what? F of x1 is equal to f of x2, and this is true for all x1 comma x2 belonging to domain. Here, which is the domain? Domain is this real number. Always the first set is domain and the second set is codomain. Remember that I write it somewhere here. Always whenever you see f is a function from where to where? A to B. Always the first set is what? Domain. And the second set is codomain. Okay? Don't forget this. Now let us come to this equation which is given. The entire thing is going to go in this. See, when I took this one here, when I wrote x equal to 0, for f of 0, I took x is equal to 0, I got this value. For f of 1, in place of x1, then I substituted and got the answer. Now here, it is f of x1. So in place of x, what? x1. So substitute here, 3 minus 4x1 is equal to, in place of x, x2. So write down 3 minus 4x2. Now on either side 3 will get cancelled. Don't cancel minus 4. Go step by step. Many will ask why, sir? Because here teacher also want to know about your basic knowledge. Students are confused whether 4 will get cancelled first or 3. Be careful. First 3 will get cancelled because you are under subtraction here. Now multiple of x1, x2, nothing but minus 4 will get cancelled on either side. Show this simplification. So let us have implies here. So this implies x1 is equal to x2, which implies f is what? 1, 1 function. In short, we can write 1, 1 also. So 1 function. First part done. Coming to onto. So coming to onto, we have to prove. We have to go with the definition of onto. Recall what was onto. We have to go from codomain to domain. We have to first find what the pre-image, okay, here, which is there. Now just see carefully for onto. Just listen first. I will consider the given function, and don't forget always it is equal to y. So actually for onto, what we are doing, for every element y in the codomain, we have to find a pre-image in the domain such that f of x is equal to y. So I am going to first find the pre-image, and then I am going to prove that f of x equal to y. Only then it is onto. Now let us go one by one. So I will take this to nothing but equating this. Y is equal to 3 minus 4x. Now I have to solve for x. Come on, solve for x. So transpose here this and here. 4x is equal to 3 minus y. Or divide by 4. Divide by 4. I will get x is equal to 3 minus y divided by 4. Okay. This is your pre-image. Nothing but x value. Okay. Same working rule is also there for finding inverse of a function, that we discuss later. Now I have to prove that f of x is equal to what? Y. Nothing but this will be the pre-image of y. Let us go ahead. So now let us write f of x. Let us consider what is f of x. What is f of x? 3 minus 4x. And I will take this as equation number 1. So in place of x, it is 3 minus y by 4. 3 minus y by 4. Now simplify. Since we have got a bracket, it's a multiplication here. 4 will get cancelled with divided by 4. 4 by 4 will get cancelled. Then we are left with 3 minus of 3 minus y. Then 3 minus into plus is minus. Minus to minus is plus. Now again you see carefully. Both plus 3 and minus 3 will get cancelled. We are left with y. And we proved it. What we have proved, understand what you are saying for onto. For every y present in codomain, there exists x present in domain such that f of x equal to y. So what we did, first we found that pre-image, and then we proved that yes, this pre-image is been mapped by f to what image itself. Okay, now when I'm going to conclude, in conclusion we will write the definition of onto. How you are going to write? Hence, for every what? Y belong to R. Y belong to R. Which R it is? They are both the side we have R, domain and codomain. Here we are talking about codomain. For every Y belong to R codomain, there exist X belong to R domain such that f of x is equal to y. Therefore, f is onto function. Now we have proved that both f is both 1 as well as onto. 1 function as well as what? Onto function. Hence I can say it is bijective, because the definition for bijective function is a function f should be both 1 and onto. Hence f is bijective function. So with this we have completed this 5 marker. Only this part you can exempt in exam, but I think this gave a clarity, because they said state whether, they didn't say prove that, so we have to check first. Okay, fine. make a note of this. Dear students, now let us move on to the next 5-marker question from model question paper number 3. I know first we have finished model question paper 1 before this problem. Now we have just move on to 3 because in model question paper number 2 we have problem on some other concept, that is invertible. Let us complete all the problem on 1 and on 2. So 5-marker question says if f is a function R to R is defined by f of x is equal to 1 plus x square, then show that f is neither 1 nor on 2. Here the word show that is there, so nothing to check. But let us have this habit now to analyze. Who knows if it comes for 1 mark for 1 on 2 very easily with the help of this arrow diagram, which I call in funny way in classroom banana. Okay, now domain is R, codomain is R. So let us write, actually see, I should write between 1 and 2. In fact, many real numbers are there, but just for explanation sake, I am just trying to write in this manner. Okay, now coming to the solution part, we have f of x is equal to 1 plus x square. Now you see carefully, 1. If I put x is equal to 1, what is f of 1? 1 plus 1 square will be 1 plus 1, nothing but 2. We are actually checking presently for 1. Now 1 is mapping to 2, fine. Take negative 1, nothing but f of minus 1. Again substitute here. 1 plus minus 1 whole square is equal to 1 as it is. Minus 1 whole square is 1, so plus 1 here. 1 plus 1, 2. Oh, minus 1 is also mapping to 2. So both 1 and minus 1, is mapping to 2. Therefore, it is not 1 function, it is many 1 function. So I can just write f of minus 1 is equal to f of 1. Don't forget, this is f of 1. F of 1 as well as f of minus 1. Correct now? So both are mapping to which number? 2. But so here images are equal. What about the pre-image? See carefully. These two are not same. For 1, if images are same, pre-image should be also same. Therefore, here we have given one example, element 1 and minus 1, for which the function is not 1. So therefore, f is not 1 function. When it is not 1 function, what it is? Many 1 function. Okay. Not only 1 and minus 1, you can take 2 also. For example, just for clarity, let us suppose we could have taken 2. So put here 1 plus 2 square. 2 square is 4. 4 plus 1, 5. Even minus 2. Minus 2 square is 4. 4 plus 1, 5. Both will map to 5. Again, it is not 1 function. One more thing. 0 if I take 0, x is 0. 0 square plus 1 will be 1. Okay. Why I did that? See carefully. I want now on to find the range of the function. One thing is very clear from here. Whatever element you have got, when you are going to substitute here, since even power is there, this will give always non-negative. Plus 1 will be always more than or equal to 1. Nothing but going to start only this element. Like this, all the element will be mapped. So many elements are left out. Therefore, it is not on 2. Let us give the reason properly. Let us write this plus properly. Let us try to find the range. See carefully. When I want to find the range, since codomain is R, so x is a real number, but I want to obtain this. So square of a real number is either always positive or equal to 0. Why 0? Don't forget in this, when I plot on number line, this is 0. This side we have plus infinity and this side minus infinity. See, these both are not there on number line. We are just saying that As and how we move towards the right, we get a huge value that we take as notation plus infinity. As and how we come left, negative value, we get very small value. So x represents this entire number line. Okay, on this number line lies there, I mean to say. And now, as soon as I've got square, all this negative term will jump here. So it will be positive. But when it is positive here, because this all negative term jumped here because of square, don't forget 0 square is still 0 only. 0 square is 0. So it is starting from 0 and moving on. That's what x square is non-negative. Non-negative means positive including 0 other than negative. I want 1. Okay, add 1. When I add 1 on both the sides, we are going to have 1 plus x square greater or equal to 1 plus 0. Or I can say 1 plus x square greater or equal to 1. And don't forget, this is what? F of x. Okay, so f of x is equal to 1 plus x square. This belongs to more than or equal to 1. So nothing but 1 to infinity. So the range of the function is from where to where? Closed interval 1 to infinity. Come to the codomain. Codomain is R. So R is entire real number. So this is subset of R. So we have come to know that therefore range is subset of codomain. Therefore f is not onto. So f is neither 1 1 nor onto. That's what they asked. Yes, we have got. Therefore f is neither 1 1 nor onto. So with this question of 5 marks completed. Make a note. Yeah, dear students, having completed the 5 marker question from 2 model paper, let us move on to the last concept. Yeah, let us move on to the last concept, composition of functions. Composition of function. And see, this will be very important for us when we start differentiation, because all the derivatives are with respect to x, whatever we are going to differentiate, we are going to have combination, combo, which I call. Just see carefully. Let us suppose that here we are going to have more than one function here. Let us suppose that f is a function from a to b. So I have got an element x in the domain, and this f is mapping this x to some element y. Okay, and that since this f is taking x to y, this will be what? F of x. Then there is one more function g, which is taking the element from b to c. So from here, and this g is taking y, okay, to some element z. So g of y. G is taking y. But what is y? F of x. So g of what is y? F of x. So it's a combination of more than one function. So f is taking a function from where to where? A to b. And g is taking from where to where? B to c. Then the composite function directly from A to C is given by G composite. This circle we call composite F. So G composite F from where to where? A to C. A to C. Now here some of the observation. And so I know, sir, why this required? Let us try to understand, no, in our real world type thing. Let us assume that this is set of A set of students, okay, and this is set of roll numbers. Now you see this, A is set of students, B is set of roll numbers. Every student will have one roll number. Nothing but what? It is one function. In our daily life also, we are in functions only. Every student will have a unique and different register number. Otherwise, how to get results? Two students having same register number, gone case. And number of student is equal to number of registered number. Nothing but onto also. Nothing but we are in bijective function. We are in bijective function. So now let us assume like this. Now try to understand this. So here A is set of students. Before I go ahead now, one more. See how to differentiate function and relation in real world. Have you ever thought? See, for function, no, we said every element should have what? Unique image. For relation, there is no such condition. Only should obey the relation given. So in our real world example, when you stand in front of mirror, you can see only one image, right? Only one image. So standing in front of mirror at home is an example of function. Okay. Whereas when you stand again in front of mirror, but in salon, nothing but where you go for haircut, etc. There, when you stand in front of mirror, you will see more than one image. It's not a function. Why more than one image? Because there is one mirror at the front and one at the back. So salon will be an example of relation, which is not a function. Whereas at home, the mirror which you see is an example of function. Okay. So come back here. So F is a function from A to B. Here A is set of students. Here B is set of register number. And here is a code given, so that let us assume like this. Okay. That examination is to be conducted. Every student have got their register number. Since exam should run fair enough, they should not be biased. Each student roll number is being given a code, so that the one who are evaluating should not know the student names. Okay. Now students are here, then they have registered number, and then here is the code for each of the registered number. Evaluation done. Now they want to know the result. So see, student can access because student knows the code. Okay, student can access. Okay, like that it is. And here one most important thing I want you to understand. See this. Here in G composition F, which is the rightmost function, I use the word rightmost. I could have said left right. Why use rightmost? If I've got more than two function also, this logic which I'm going to say will be true. Here the rightmost function is F, and you see this domain of F is A. So rightmost function, whichever is present, that domain is present here. Okay. Next, here C is then codomain. C is codomain of what? G. So leftmost function codomain is here. Leftmost function codomain is here. So now this, when it's going to map, so here G of F of X is actually here G circle F of X. We call sometimes circle also composite. G composite F of X is given by this. This is true for all X belonging to domain. Domain is what? A here. Okay, who knows, for 1 mark, they might have given G composite F, and they might have asked which is among this in the option, which is the domain and codomain, and they have given this. So always domain is rightmost functions, domain will be, and codomain will be leftmost functions, codomain. Okay. Now having this, let I give two properties here, which who knows it will be helpful for 1 marker. The property is same like matrices. Here commutative need not be true. Mean to say G composition F need not be equal to F composition G. But in case of invertible, it will be true. Special case, which we'll take shortly. And one more, G composition F composition H is same as G composition F composition H. Nothing but associative is true. Associative holds. whereas need not be commutative. Need not be commutative. See, when I'm saying need not be commutative, it means for some problem agree, for some problem disagree, then that we cannot take as a property. The one which is always true irrespective of whichever problem we take, that we take as a property. Okay. Now last concept, invertible function. It is same invertible matrix logic, same ways. Now what is invertible function? A function, let us write the diagram here. A function f from where to where, let us suppose x to y, is said to be invertible if there exists a function g from y to x such that g composition f should be identity function and f composition g should be again identity function. Now below the I will usually give a rectangle box where you have to fill the domain here. For that reason itself, no, I gave this concept. How to know domain, rightmost function, whichever the function is there, that domain you should write. Now just see here. In this, which is the rightmost function, f. What's the f? Let us write it here. F is a function from where to where? X to y. And g is a function from where to where? Y to x. We are coming back. So here x is there. X is been taken by f. So I am getting f of y. Again we are coming back. So g is taking back. Okay. So since rightmost function is f, domain of that is x. So I wrote x here. And g is a function from y to x. So since rightmost function is g, so what is the domain of that? Y here. And this time it is commutative. Okay. So a function f is said to be invertible if there exists a function g from y to x such that gof is identity function and fog is also identity function. And here I just gave a nickname as gof and fog, which should be as g composition f and f composition g. Now here we denote g, since g is what now? Inverse of f. See how we are going to read. See this, g is inverse of f, and I would like to say that this is not reciprocal. Don't think as a number. In school days, yes, 2 power minus 1 is 1 by 2. This is correct because 2 is a number. F is not a number, it's a function, which is just saying that we are taking the element from codomain to domain. Okay. Now one last point I want to discuss. With that, all the concept is completed. For a function to be invertible, apart from this definition, do we have any condition? See carefully. I'm just going to erase this, make a note, and then I'm going to take 3 examples where you have to, you'll get a clear-cut idea. Okay, one more condition for invertible function. Okay. So now, dear students, I'll be giving 3 examples. You have to comment about whether it's a function or not a function. Okay. See carefully. This is the first example. F1 I will write. I'll take the same elements. So I'll write A itself, okay? Because I want you to have some clarity here. Only I will change the mapping. Enough, 2 is sufficient, I think. Ready? Can you go ahead? F1, is it a function? Element 1 has got 1 image, element 2 have got 1 image, element 3 also have got 1 image. Yes, it's a function. What about this? 1 have got image B, image of 2 is C, image of 3 is A. Only one image. Therefore, both are what? Functions. Now, I want to go back. Now, you take this as G1. Now, see, F1 you have taken left to right, okay? Left to right. Now, you see G1 right to left. Right to left. Now, check whether G1 is a function. For it to be function, every element should have how many? Unique image. Image of A, 2, one image. But you see B, for B there are 2 images. Therefore, G1 is not a function. And one more thing is G1, element C of G1 don't have, mean to say element C of B don't have any image. Therefore, it's not a function. One more reason. Come here. Here what we understood here, F1 is neither 1 nor onto. Come here. F2, is it a function? Yes. Is it 1 check? All have got different image, and range and codomain both are same. So F2 is bijective. F2 is bijective. Now come behind. Mean to say come from codomain to domain. Is your G2 a function? So from right to left, okay? Image of A, 3. Image of B, 1. Image of C, 2. Every element of B have got only one image with respect to G2. So it is 1 function. And for G2, B is the domain and A is the codomain. And range and codomain are same here. So I can say that G2, whenever F2 is bijective, this also implies that G2 is also bijective. So mean to say that whenever a function is invertible, inverse, see this G2 is now what? Inverse of F2. So the alternate definition or condition of function to be invertible is the given function should be bijective. As soon as the given function is bijective, inverse exists. And the function which exists, no, the inverse function, that is also what? Bijective. I hope this point is clear. So whenever a given function is bijective, its inverse is also bijective. So apart from this definition, this will be the other condition for a function to be what? Invertible function. Okay, fine. So again, this is not equal to 1 by F2. Now with this, let us take the last 2 problems. Okay. Yes, student, this is the last 5 marker question. After this, we have one question from MCQ, 1 marker in model question paper 3. Now first, let us go ahead with this. This is a 5 marker question. Question says, consider a function f from R to R. So domain and codomain is again R and R, given by f of x is equal to 4x plus 3. Show that f is invertible and find the inverse. Now since the word invertible is used, so we are going to go with the concept of invertible function. Don't forget there we have went for this. If f is a function from where to what, where to where? X to y, then g should be a function from y to x, such that g composition f should be identity and f composition g should be identity. And here I should write the domain of the rightmost function. Rightmost function here is g, domain is y, so I write y here, and here rightmost function, okay, I wrote again the same. Here it is g composition f, rightmost function is f, what is the domain? X. So we have to get, now here most important thing, now f is known or given in the question, g is not given. See, to find g, understand this, to find g, nothing but to find inverse or onto, for all the 3 same, nothing but we have to find pre-image, we have to find pre-image, nothing but x we have to solve for. So solution, see carefully, let us take the given question and now we have to solve for x, so equate to y. Now take or equate y and the given function 4x plus 3, solve for x. So here we are solving for x, so I can transpose this. we get y minus 3 is equal to 4x, or y minus 3 divided by 4, since product of two term cross multiplication. Now this is our pre-image. Now see this carefully. Since this entire term is in terms of x, so it is function of x. Now this is in terms of what? Y. So this is a function of y, so g of y. Now I have to prove that g is inverse of f. How to prove? This condition should satisfy only then g is inverse of f, where this is not equal to 1 by f. So I have to go for this too. Now let us go ahead one by one. See carefully, pay attention to prove invertible. To prove what? Invertible. And if you just see and recall, when we went for on to, same step we did, only thing is we didn't call g of y. Okay, fine. Now let us proceed. G composition f. Now here which element should be written? Very simple, f. F contains x. So this is my equation number 1 and this is my equation number 2. So here, since f contains x, so I am going to start with x here, and as we know it is g of f of x, and this is for all x. X is coming from domain of the rightmost function f, and f domain is what? R. So x belongs to R. Now one by one simplification. From school days we know we have to solve from innermost bracket, which is f of x. So what is f of x from equation number 1? 4x plus 3. Substitute. How I got this from equation number 1. Now g of this, in place of y we have got this. Many students feel difficult to handle this, so I prefer to take some a. Assume a to be what? 4x plus 3. Now things are a bit easy to handle. In place of, see, g of y, since g is there, I am coming to equation number 2. Whenever f is there in equation number 1. So g of a. So in place of y, a. Substitute here. A minus 3 divided by 4. How I came to know this? From equation number 2. Now let us substitute back what is a. A is 4x plus 3. So in place of a, it is 4x plus 3. Then minus 3 divided by 4. Minus 3 whole divided by 4. Now simplify. Now again question mark is, are you going to cancel 4 by 4 or 3 minus 3? Basic knowledge. So again here, see, this is whole divided by 4. You cannot cancel 4 by 4 because if at all you want to cancel, this 4 should be a common in numerator. I hope this point is clear. It should be present here as well as here. Only then you can take 4 common out and then you can cancel. So here only plus 3 and minus 3 can get cancelled. Next step, 4x by 4. Now what is going to happen? Both plus 4 by 4 will get cancelled and I am going to left out with x. Don't forget the left hand side. G composition f of x. Okay, write down. Now you see carefully. We started with x and we got back x. That's what? No, identity function. Y equal to x. Whatever input you get, whatever input you give, same output you give. That's what we said. Identity we should get. Yes, we got. This implies G composition f is equal to identity, and here I should write domain of the rightmost function. Here who is the rightmost function? F. What's the domain of that? R. So write down R. So we have finished with the GOF. Now we have to go for FOG. Same procedure. F composition G. Now what to write? Which element? Come to G. What's the element here? Y. So start with Y, which is same as, write properly, which is same as f of g of y. And again this is true for all y belongs to. See carefully. For f, the function is from R to R. So as per this logic, G codomain of F becomes domain for G, and the domain of F becomes codomain. Correct now? So here, since both are same, again when I talk about G, it is R to R only. This R came here and this R came here. So Y belongs to domain, because rightmost function is now G. So domain of G is R. Now this is inside the bracket. So tackle G of Y first. G of Y is there in equation number 2. So G of Y is Y minus 3 by 4. Y minus 3 whole divided by 4. And this I got from equation number 2. Be careful, some students will write like this. No, it's wrong. You are saying only 4 is dividing minus 3 but not Y. It is whole divided by. Don't compromise with your basic. Write the whole divided by properly. Okay. Now again, this is difficult to handle. In case it is difficult, take as some B. Where B is what? Y minus 3 divided by whole divided by 4. Now F of B is there. F of X is 4x plus 3. Okay. So in place of X, what do we have? B. So substitute here 4B plus 3. How I got this? From equation number 1. Now, just write it neatly. But now what is B? See carefully. In place of B, this entire term 4 into B it is. So bracket. Then now what is now? Y minus 3 divided by 4 plus 3. Sum of the thing will get cancelled. Can you see 4 by 4? Both will get cancelled. So we are left with Y minus 3 plus 3. Again, see now in this case I was able to cancel 4 by 4 because 4 is common for this two term, which was not the case here. Okay. Now minus 3 plus 3 are getting cancelled. I'll get what? Y. What is the left hand side? F composition G of Y. See again. See this step again. We started with Y and got back what? Y, nothing but identity function. So I can write here. Therefore, or this implies F composition G is equal to identity function. And I should write the domain of rightmost function, that is G. What is the rightmost function? Rightmost function is G. So for G, what is the domain? R. So R. Therefore, I have proved Goff and Foggy's identity. Since it is identity, I can comment now that G itself is inverse of F. So G of Y, which is inverse of Y. And what is that? So now this is what? Y minus 3 by 4. This is the inverse. So question was, show that it is inversible. Yes, it is invertible. And find the inverse. Yes, this is the inverse. Okay. And one more thing. Sometimes it happens, no? It can also be written as F inverse of X. See, it's a dummy variable. In place of Y, I can have X also. So R. So wherever Y is there, X. So I'll get X minus 3 whole divided by 4. What's the meaning of this? I am writing in terms of Y. Now here I am writing in terms of X. Okay. So with this, the 5 marker is done. Kindly make a note of this. Yeah, dear students, we have with the last problem, 1 marker question. Question says, and it's from model question paper 3. Okay. KSEAB. Okay. Issued by KSEAB. Question says a function f from R to R defined by f of x equal to 2x plus 3 is bijective mapping. Then we have to find the inverse. Okay. See, coming to bijective mapping, nothing but should be both 1, 1 and onto. That's what I discussed, correct? For a function to be invertible, it should be both 1, 1 and onto. And even if they won't give also, no, R to R, power of x is what? Odd number. So it is always 1, 1 and also onto. Whenever power of x is odd and it is R to R, it's always bijective. Okay, power is odd. Okay, only odd power should be there. For remaining thing, we can, if it is even etc., then we have to analyze. Okay, depending on domain, codomain. Now I want to find f inverse. So solution. So what we just completed 5 marker question, finding G. Till there, if you do, job done. So equate to y and solve for x. So take this to y is equal to 2x plus 6. Transpose this. Solve for x. Y minus 6 is equal to 2x. Divide by 2. So I will get y divided 6 whole divided by 2 is equal to x. Or I can say cross multiplication. Correct? Now, if you see the option all items of x, that's what I said. This is actually g of y, which is f inverse of y. Now I want to write in terms of f. So in terms of x, f inverse of x is equal to, so in place of y, x. So x minus 6 whole divided by 2. But here they have surely this 3 option out because there's no division. But to match with this, 2 want to divide x also and minus 6 also. Fine. X by 2, split them. 2 ones are, 2 threes are. So answer is x by 2 minus 3, which is mapping with option A. Yes. So kindly make a note of this. So with this, all the question from relations and functions completed. Okay. Yeah. Yes, dear students. Now time for assignments. These are the 2 questions I have given for assignment. Both are 5-marker question. And if you see, both are same function, but here I'm asking to prove it is invertible and then find inverse. And here it is talking about injectivity and surjectivity. Okay. So with this, we come to an end on relations and functions question paper, model question paper problems. Okay. So exam is coming nearby. Okay, each day you are approaching near to the exam. So make sure you have a habit of writing and practicing. Surely after watching the video, as soon one problem is completed, put a pause, then copy down and then go for next. Okay, you should write and practice. Okay, so God bless you all. Give your 100%, do well, and do share, like and subscribe to my YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.